So hi everyone, welcome to a special edition of the IIF International Investment Forum. Today we're going to be discussing the monkeypox that is now spreading over Europe and North America. And I have the pleasure to be joined today by Dr. Moutih Rafei, lead scientist, VP R&D Director at Defense Therapeutics. Moutih, how are you doing tonight?
Well, I'm doing very well. In fact, it's still in the early time of the day. We're not in the evening right now, but you guys, I guess, are more advanced. So early afternoon.
Yeah, exactly. And I think this is one of the big characteristics of the IIF. We join people from all over the world. So often when it's evening here, it's morning somewhere or even middle of the night on the other side. So Definitely. We're very, very pleased to have you. Thank you very much for taking the time to discuss something that is rising as in the news, that people are reading everywhere, but that there might not be yet enough or a lot of explanation about it, which is the monkeypox. So Moutih, maybe you can explain us what is basically the monkeypox?
Yeah, so the monkeypox is basically a virus that is coming from the same family as the smallpox, which everybody is already aware of. It's basically a virus of the orthopox viruses, which is found in nature, more specifically in rodents. It's been identified naturally in rodents, in rats, squirrels. It's been also identified in primates, or non-human primates. And this is basically a virus that once it infects a human, it will eventually lead to fever, lots of pain and aching muscles. Patients feel eventually very tired, and they have swollen lymph nodes. And really what is distinctive about this virus, like the smallpox, is that it will lead to rashes, so skin rashes, blisters, and eventually, these burst, and the liquid could be infectious and so on. So it's very, it's a virus that is actually very close to the smallpox virus. And that's why we say, for example, that people that got vaccinated against smallpox when they were kids, they have a good chance to be, I would say, 80 to 85% protected against the virus.
And so if I understand correctly, so the name monkeypox is because first it was identified on monkeys, but now it's no more the main transmission way, is it?
Well, it's been called the monkeypox, but honestly, the natural reservoir, it's been discovered, I think, in the late 50s, 1950s in non-human primates. But after that, when people started, investigating on this virus, they found that it's mostly found in rodents in Africa. So squirrels, rats, and really the mode of transmission initially from, these are all speculations based on what we know about nature, right? For example, if you ask me what's where did HIV appear from the first time, I can give you 20 different hypotheses, but nothing could be really given in a solid way. So one of the ways people have been saying is that these infected animals get into the house, they bite onto something like meat or any kind of food that you're going to be consuming, or they bite the human itself. That could be a mode of transmission. After that, from human to human, well, they were talking about blisters that can, liquid that can come out, bloody fluids. Some people are saying it could be an outbreak that could be caused by the droplets, like, for example, if you're sneezing. So really any contact, if you're sleeping in the same bed with someone who's infected, you can be infected. And that's really the way how smallpox is being transmitted. I mean, when kids have smallpox, eventually the whole class is going to have it. And so it's the same kind of transmission. And one of the reasons also that we have to keep in mind is that there is a reason why mostly kids are getting it right now, because that's probably the stage where we usually get smallpox. So it's probably going to spread. I'm hoping not, but it most likely, if it's not controlled tightly, it could be spread all over the world pretty quickly.
Yeah, and talking about that spreading, this is not the first outbreak there's been. Historically, there's been in 2003 and just a few outbreaks, but very limited. However, it seems this time that since May 7th, which was the first European case confirmed, an individual returned to England from Nigeria, there has been Portugal, 14 cases, Spain, 7 cases, United States, Sweden, Italian authorities. It seems to be spreading relatively fast, even if the numbers are still low.
Yeah, I mean, there could be many reasons for this. I mean, first of all, people nowadays travel much better than before. If you look at the 70s or the 40s or the 50s, the mode of, moving from one country to the other became bigger. The population has increased. We have to keep in mind also that our strategies or technologies nowadays to diagnose, to pose a diagnostic for these patients has improved dramatically, which means that now we can find out more and more and more of these outbreaks. Also, authorities nowadays are pretty concerned about infectious diseases. I mean, we've seen with COVID, some countries initially tried to hide the stories, and then things got, uncontrolled. And that's what led now to authorities being very strict on, confirming or reporting these things. Plus, one other thing you have to keep in mind also is that viruses, by nature, they're basically a capsid of protein containing genetic material. So their objective in life is to spread, and to spread, they have to evolve. And that means they become much more virulent. They will actually capture pieces of DNA or RNA, they will combine them, so they become much better at infecting and spreading than the initial strains. And that's really the power of viruses.
And you're touching something very important here. And basically that means that could it get more transmissible? Could it be a more global threat than what it is right now, which is very limited at the moment?
Well, you've seen, I mean, we've spoken about the first couple of cases about a week or 10 days ago, and now suddenly you have 6 or 7 countries reporting these things. So honestly, it could spread pretty fast if we don't really control it very efficiently. And controlling viruses and controlling infections nowadays, it's not easy, especially that now people are getting out of COVID and they're trying to really get back to normal life. So now if you can put them back into a lockdown because of this, it could become problematic. It's really up to the WHO to really decide what's the best approach. Should we put, for example, people on antivirals? Should we perhaps check if people got the smallpox vaccine, because not everybody has been vaccinated against smallpox. So these are all things that the authorities have to sit down and discuss.
And as a researcher yourself, specifically in that domain, how do you assess right now how effective drugs or vaccines are against monkeypox? And can you tell us a little more about the possible ways to actually tackle that virus?
Well, smallpox has been around, a long time ago, and really the initial vaccination against smallpox was really to transmit the virus from one person to the other, because at the end of the day, people do recover. They get pretty sick, but then they recover, and that's really the best natural immunity you can develop. Now, there has been a variety of vaccines that have been developed and tested. These are all live attenuated vaccines. So they're viruses that have been kind of mutated in vitro to be able to infect, to mimic the infection, sometimes give side effects which are really close to what we get from the infection itself. But that's really that remains the best effective method right now to really protect the population from that virus. For example, there's the Dryvax, there's the ACAM 2000, there is the MVABN, which has multiple names depending where you are in this country. So they're all live attenuated viruses, and so because of this is not a virus, I don't think there will be at the moment a strong looking or a strong interest in looking for the development of a novel vaccine against that virus, unless tomorrow you tell me, oh, 10%, 20% of people are dying and the vaccine is not effective. That becomes a major issue right now. So I think if people have to, if the authorities have to start thinking about a method to control it rapidly, they might be thinking of putting these patients on antivirals, and there are probably 2 or 3 drugs out there that could help, to speed up the process of recovery. Now, from our perspective, infectious diseases is going to come back again. I'm sorry to say that, but there will be future outbreaks. We've seen it with the polio, for example. When people got all vaccinated against polio, it disappeared. Then some anti-vaccine groups came back. People stopped using the polio vaccine in certain areas of the world, so it came back again. So these are, evidence that these viruses are not completely eradicated. You have tons of these viruses in nature in different hosts. And today, unfortunately, people eat anything. And so that could be also a source of transmission of these viruses, novel viruses, and also with global warming that, is making new carcasses appear in the North Pole. Animals are eating on these carcasses. So there might be various theories, but we should be prepared to face future pandemics or future outbreaks of different pathogens.
Absolutely. And in that regard, in the regard of us thinking about the future and future protection, as the lead scientist at Defense Therapeutics, what can your company provide in that regard? How can you guys, with the technology which you're developing, the ACUM technology, could that be a fit? How would you see the future of ACUM, for example, to treat monkeypox?
So the advantage of the ACUM is that it could be applied to any kind of disease or indication as long as you have your protein, DNA, or RNA sequence. So in our case, we have, for example, developed quickly a vaccine against COVID, both that is delivered injectable vaccine versus an intranasal. We have also demonstrated that our technology works with the HPV protein. So the answer is yes, we can apply the ACUM to develop a new protein-based vaccine against smallpox and or monkeypox, as long as we have access to that protein. I don't think live attenuated vaccines are going to make it back. People are no longer interested into injecting live attenuated vaccines. Most of the vaccines right now are going to basically be subunit vaccines, protein vaccines, or even RNA vaccines. And so ACUM could be applied rapidly to generate a protein-based vaccine against monkeypox by just linking the molecule directly on the protein and admixing it with an adjuvant and liver to. So all what we need, honestly, is the protein, the target protein, and that's it.
And so this is very promising, obviously, and this is yet a possibility, as you didn't obviously test it yet, but theoretically it could work. This is what you're saying.
Yes. We've done 2 different vaccines against 2 different infectious agents, and we've seen fantastic results.
And so maybe another thing that is interesting is that the ACUM would not necessarily need to be injected as a normal vaccine through a syringe in the arm or so on. You are also working on different ways of actually bringing the molecule within the body that would people feel less intrusive, maybe.
Yes, we're definitely looking to develop, because we know that these airborne infections are basically not done through blood or skin contact. They're mostly done through air. So, lipid droplets or air droplets that are basically transmitted. And so I think the next generation of vaccines, if we want to really constrain this pandemic or this outbreak, is to develop these intranasal vaccines, where people will develop a mucosal immunity against the virus, which will block at the entry level the virus from the body. Because, for example, if you look at blood-borne diseases or infectious agents that are transmitted by blood, these could be controlled because we can protect ourselves against these things. But when it becomes a virus that is airborne, just sniffing some air in an airplane that is basically infected by another person, that's a source of infection. So if we don't really develop this mucosal immunity to have IgA antibodies to protect from the initial stage of infection, I think we're not going to go far in that regard. And the best example I can give you is the COVID vaccine. The COVID vaccine we all got lately actually generates a very strong and good immune response, but it doesn't actually protect from the initial stage of the infection. And that's why everybody who's been vaccinated is still prone to get the infection, except that they don't go to the ICU. So that's an example that, intranasal vaccines should be the next target for outbreaks. And that's really what defense is trying to achieve with the ACUM technology.
And so basically, if I hear you correctly, what it does is that it both stop the contagion right away, meaning that if I get that intranasal vaccine, I won't be giving the virus away anymore. And also I will be protected, obviously, in case I get it.
Yeah, so So the best explanation I can give you is that there are antibodies that neutralize the virus. These antibodies have been divided in different subtypes. So the most effective blood is IgG. And so IgA antibodies, on the other hand, are the ones that are usually found in the mucosal sites. So in the nose, in the mucus of the stomach, in the the vaginal or the rectal area. So anything that is kind of surrounding the anal cavity and the mouth. And so if you have IgA antibodies, so these IgA antibodies are going to neutralize the virus, and so they won't allow the virus to infect the cells and get systemically. The best natural example I can give you is a lactating mother. So if a baby is lactating, maternal milk, and these maternal milk are the best transmission of IgA antibodies, the baby is going to be protected. I've seen it myself. Mothers could be sick, but the baby is never sick because the baby has all the antibodies in the mucosal sites that are protecting it from getting infected. So this is why we believe the intranasal vaccination with the ability to generate the IgA antibodies could be the way to go, because they will block the virus at the initial stage. And if you're not infected, you can't infect someone else.
This sounds very, very promising for sure. And back to the monkeypox, because we have to come to an end. What advice would you give to people out there that are maybe closer to localities where there are cases right now? I think if you're not close to any of those localities, there's no reason to panic or to be stressed right now, as the virus not be there. But yeah, what would you give them as advice?
Well, as a general advice, I always say, these are infectious agents. Their job is to infect people. So you have to really take your precautions. I would not recommend, honestly, removing masks. I would not recommend washing your hands. I would not washing your hands. Sorry. I would not recommend, putting your hands close to your mouth or face. I know with kids, it's difficult to control these things, but we have to take our physical precautions to start with to try and minimize, or at least let this infection move away, because that's an infection that takes about 2 to 3 weeks, right, for the incubation time. So you have to be sure that we could be patient for the next month or two to really constrain the infection and not really get into an outbreak now where we have to go into another lockdown and search for another vaccine. And hopefully, if that's done, we should be able to move along and hopefully resolve that issue.
Well, thank you very much for the advice. I think it was very useful to have you here with us, to explain us a little more. We understand a little more where it comes from, how it's transmitted, more specifically how dangerous it is or not, and obviously I think that's the way forward to be able to, in the near future, protect ourselves with different type of vaccines. One being developed, one solution being developed by Defense Therapeutics in the vaccine sphere, not specifically obviously for monkeypox, but the equivalent could be done. So I think our viewers can have a very better idea of what's happening with that new outbreak right now that is in North America, Europe, coming from Africa, as it seems right now. Dr. Rafei, I thank you very much for your time. It was very interesting, and I hope the situation does not develop, so we don't need to talk again about this outbreak, but we'll be very happy to do so in case.
Thank you very much. My pleasure. Thank you.